Okay, so this afternoon we're going to look at another bisection example. We're just going to look at two examples. After these two examples, you should have a good feel of how the method works with the first example we looked at yesterday and this one. Okay, the difference with this one is that there's a bit of a trigonometric component, and I'm going to explain how you're supposed to do this. The first thing you're supposed to be aware of, first of all, the question says find the root of the equation f of x equals to cos x minus x plus 1 equals to 0. So we want to find the value of x for which this function has got a root in the interval 0 to 3. So if you look at just this function in this interval 0 to 3, basically we have a graph which gives us an idea of what it is we're looking at. So this is the function in the interval -1 to 4. So you can see like that, there it starts dropping, then it cuts the x-axis somewhere there between 1 and 2, and it goes like that. So basically there's more of this function happening, but our interest is in this particular region where we have got a root here. So with the interval we have chosen, 0 and 3, from this graph, you can see that there is actually a root. There is a solution to this function f of x equals to cos x minus x plus 1. Is it clear?
Yes.
Okay. The next thing is, when you are dealing with trigonometric functions like cosine and sine, we do not use angles in degrees. The numbers we use are angles which are given in radians, like just normal counting numbers, 1, 2, 3, 4, 5. But those numbers are not in degrees. Those numbers should be in radians. So how do you do that on your calculator? I don't know what kind of calculator you have, but mine, it's a Casio FX82MS. If you press on mod repeatedly, there is somewhere where it gives you something called degrees, rad, and grad. Then you press the number 2, then it starts displaying your angles in radians. I don't know what kind of calculator you have. What kind of calculator do you have?
I think mine is a Dell. Daily, something like that.
So
But it does what you are saying.
You know how to change from radians to degrees?
Yes.
Okay. So the first thing is, when you're doing, especially with your computer and also in this course and with the computer, we consider our angles only in radians. Are we clear? So if you have a cosine, you've got a sine and everything else, you need to change your angle. You need to set your calculator so that it accepts angles which are given in radians. That's the first thing. So from the graph, we know that there is a solution, or there is a root between 0 and 3. So how are we going to do the same process with bisection so that we can actually find an answer? So of course the interval AB, in our case the interval AB is 0 to 3. So in this case, our A, the lower boundary for our bracket is A equals to 0, and the upper boundary B is 3. Is that clear?
Yes.
Okay. Next, we want to find out if there is a solution between in this bracket 0 and 3. So the first thing we have to do is, of course, we need to evaluate our function f of x at A, and you also need to find out what our function is at B. So we need to evaluate f of A and f of B. So in this case, f of A is going to be equals to f of 0, and with that f of 0, so you end up having cos 0 minus 0 plus 1. This 0 you have here, this is not, and I'll repeat this, This is not an angle in degrees. This is a number. And these numbers, whether it's 1, 2, 3, they've got units called radians. Are we clear? Hello?
It's clear.
Yes. So, with your angle set in radians, with your calculator set to accept angles in radians, you type cos 0 minus 0 plus 1. So, cos 0, we know cos 0 is 1. Minus 0 plus 1, this gives you 2. So, f of A is 2. Next, you move on to f of B. F of B is equal to f of 3, which is going to be cos 3 minus 3 plus 1. And that's going to give you minus 2.989992,497. What do you see here? You see that f of A is 2, f of A is positive, then f of B is negative. So as our function shifts or moves from 0, when it's at 0, it has got a positive value. Then as it moves to 3, the value it has changes to being a negative valued function. So somewhere, the function changes from positive to negative. Are we clear? And that is exactly what you see with this cave. This cave, before this point here, it's a positive valued function. This side, it has got positive values. Then when it reaches here, when it goes aside, it ends up having negative values. So how do we use this information to find out if the function has got a root in this interval? So basically, for us to check if there is a root in the bracket 0, 3, you have to work out this product. You have to multiply f of A times f of B. If you multiply f of A times f of B, then you find that your product f of A times f of B is greater than 0, then you know that there is no root. Basically, it simply tells you that the function did not cross the x-axis. If on the other hand, f of A times f of B, when you work out this product, then you find that this product is a negative valued product. Then it shows that this function crossed the x-axis. Are we clear? So this is how we check. This is how you check if the bracket you have chosen is the correct bracket. Okay, so we multiply f of A. F of A is 2, then f of B is this value here, minus 2.998 something, which is very close to 3. So you end up having f of A times f of B, which is going to be 2 times minus 2.98992,497. This is going to give you minus 5.979984993. This product which you have here is negative. It's negative, meaning that it's less than 0. Are we clear?
Yes.
Since our product f of A times f of B is negative, this shows that a root exists in the bracket 1, 3. So this is how you would check if you didn't have a graph of what this function looks like. If you don't have a graph, then you'd check like this. Okay. So now that we are convinced that there is a solution in this bracket, the next step we have to do is we have to find the guess value. Okay, and the guess value we use is what's referred to as a midpoint, and that midpoint is denoted as C. So for us to get our midpoint C is going to be equal to half A plus B. So in our case, A is 0, B is 3. So our midpoint C is going to be equals to, in this case, we're going to have, and so our A is equals to 0, our A is equals to 0, and our B is equals to 3. So in our case, our midpoint C is going to be equals to half 0 plus 3. This 0 plus 3 is just the same as 3, so we end up with C is equals to half 3 and you end up having C is equals to 1.5 as our midpoint. Are we clear?
Yes.
So this is our first root, our first guess value of what the answer is supposed to be. After finding C, now we have to evaluate what is the value of the function at C. So in this case, we have to find f of C, which is equal to f of 1.5. So that case, f of 1.5 is going to be equal to cos 1.5 minus 1.5 plus 1, which gives us this, a negative value. So the function has got a negative value at C, minus 0.429262,978. So with this, the next step is to check if there is a root between A, which is our lower boundary, and the midpoint. And how do we check if there is a root between some numbers? We multiply the value of the function at those particular points. So in this case, we have to work out this product, f of A times f of C. We know what f of A is, and we have just worked out f of C. This is f of C, the value of the function at C. F of A, we have it here. F of A, this is what we have. F of A equals f of 0. So that is, f of A is 2. So that bit we already have. Then f of C, which is equals to f of 1.5. This one we have just worked out here. Okay, so we work out the product. So we're going to end up having f of A times f of C. That is going to be equals to 2 multiplied by our minus 0.429262,978. So what we're doing here is we are multiplying a positive number times a negative number. So if you multiply a positive number times a negative number, we end up with a negative number, a negative product. So we end up with minus 0.858525956, which is less than 0. So our product is negative. What this negative is showing is that between A and C, the function cuts the x-axis between A and C. So there is a change of sign from A, which is positive, to a C, which is negative. So between A and C, our function cuts the x-axis between A and C. Is that clear? Okay, so as I was saying, this negative product of f of A and f of C means that, or shows that, the value of our function changes from positive to negative between A and C. So that shows that there is a root between A and C. Are we clear? Is it clear?
Yes, it is clear.
Okay, so since that's the case, since our product f of A times f of C is negative, there's a root between A and C, so we're going to shrink the upper boundary. The upper boundary at the moment is at 3. So we're going to move the upper boundary so that it comes to 1.5. So we make our midpoint C become B. So B is going to have 1.5. So B is going to become 1.5. And also the value of the function at the midpoint f of C, that's what's going to become f of B. So f of B is going to become this. So our B is now 1.5. If our B is 1.5, then our bracket is going to shrink. From being 0 to 3, now our bracket is going to become AB is going to become 0 as our lower boundary and 1.5 as our upper boundary. So our bracket has shrunk from 0 to 3 to now being 0 to 1.5. Are we clear? Okay, next, now that we've got a bracket which runs between 0 and 1.5, we have to work out a new midpoint. So in this case, we calculate a new midpoint using the old A equals to 0 and our new B equals to 1.5. So our new midpoint C is going to be equals to half A plus B. So that's going to be C equals to our A is 0, our B is 1.5. So that's going to be 0 plus 1.5, that will be 1.5. 1.5 divided by half is going to give us a C which is equals to 0.75. So this is going to be our new midpoint, 0.75. Is that clear?
Yes.
With this C equals to 0.75, we are going to evaluate the value of the function. What is the value of the function at C, at our midpoint? C, f of C, which is going to be f of 0.75. So that's going to be f of 0.75 is going to be cos 0.75 minus 0.75 plus 1. And this is going to give us this 0.981688869. So this value is a positive value. So this is telling us that our function at the midpoint has got a positive value. Are we clear?
Yes.
So we check again. The check we are doing is always between the lower boundary and the midpoint. Is there a solution between the lower boundary, which is A, and the midpoint C? And how do we do that check? We work out the product f of A times f of C. Now, our A is 0 at the moment, and our C is 0.75. So, f of A, we know f of A is 2, and our f of C, which is 0.75, we have just found out to be this. We have found it to be this. So, we're going to end up with 2 times 0.981688862. This f of A is positive, it's 2. This f of C is a positive number. So we are multiplying two positive numbers. When you multiply two positive numbers, we end up with a positive product. 1.963377783. This is positive. Since the product of f of A times f of C is positive, it means that between f of A and f of C, our function f of x has not crossed the x-axis. So the root does not exist between A and C. There is no root between A and C, because the product of f of A times f of C is positive. So there is no root. The function has not yet cut the x-axis between A and C. Is that clear?
Very clear.
Since the function has not yet cut the x-axis, we can shrink A. We can move A up so that C becomes A, our A. So we shift our boundary a bit up. So our A becomes 0.75, and our f of C now becomes f of A, which is going to be 0.981688683. So with this change which you have made to our lower boundary, now our bracket will shrink from being 0, from AB being equals to 0 to 1.5. Now it's going to become 0.75 to 1.5. So this is going to become our new bracket. So we know that in this bracket, 0.75 and 1.5, somewhere in these brackets, our function cuts the x-axis. How do we know that? Because with this bracket at f of A, our function is positive, and at 1.5, our function has got a negative value. Okay? So with our bracket having shrunk, up and down, we recalculate a new midpoint using our new value of A, which is 0.75, and our old value of B, which is 1.5. So C is going to be equals to half A plus B. So C is going to half. So our A is now 0.75 and our B is 1.5. So 0.75 plus 1.5, that's going to give you 2.25, and 2.25 divided by half, that's going to give you C is equals to 1.125. So this is going to give us our new midpoint. So our new midpoint is going to be C is equals to 1.125. With this new midpoint, we want to find out what is the value of the function at this midpoint. Is the function positive or negative? Are we clear? That's what we want to do. You want to find out if at this midpoint the function is positive or negative. So f of C is going to be equal to f of 1.125. So that's what we have here. So that's going to be cos 1.125 minus 1.125 plus 1. And this is going to give you 0.306176516. This is positive. Our function at the midpoint is positive. Our function at f of A is positive. So we check if there is a solution between f of A, between A and C. Our A is 0.75. Our C is what we have just found here, 1.125. So at our C and our A, we work out the product, f of A times f of C. So f of A, that's what you have there. That is this what we have here. It's positive, and f of C, it's also a positive value. So we have got 0.981688863 for f of A. Then for f of C, we have got 0.306176 This is a positive number. This is a positive value. This is a positive value. We multiply these two positive values, we get a positive. Are we clear? This positive is greater than 0. So since the product of f of A times f of C is positive and is greater than 0, it shows that our function has not crossed the x-axis between A and C. Therefore, if the function has not yet crossed the x-axis between A and C, there is no root between A and C. If there is no root between A and C, then we can proceed to move our lower boundary A. We move A so that A becomes C. So that's what you have here. So C now becomes A. So our value of A is now changes from what it was, 0.75. Now it becomes 1.125. And the value of our function at the midpoint now becomes the value of our function f of A, which is now 0.306176,516. With that change, our boundary our bracket has now shrunk. Now f of the bracket AB is now 1.125 to 1.5. Is this clear?
It's clear.
With our bracket having shrunk like this, next we rework out using our new bracket values, we work out a new midpoint. So the new midpoint is going to be based on A, which is equal to 1.125, and on B, which is equal to 1.5. So our midpoint C is going to be equal to half A plus B. So that's going to be C is equal to half 1.125 plus 1.5. So that's going to give us C is equal to half 1.125 plus 1.5 is just going to give you 2.625. Then half of 2.625 is C equals to 1.3125. So this becomes our new midpoint. with C becoming our new midpoint, the next thing we do is we want to find out what is the value of our function at the midpoint. Is it positive or negative? So that we can judge if our function has already crossed the x-axis or not. So in this case, f of c is going to be equal to f of 1.3125, and this is the evaluation of that calculation of that particular function. So that's going to be cos 1.3125 minus 1.3125 plus 1, and we get minus 0.5 minus 0.057066,233. You can see that our function at this new midpoint is negative. Is that clear?
Yes.
That means that our function has crossed the x-axis. Between A and C, it means that our function has crossed the x-axis. And how do we confirm that the function has crossed the x-axis? We work out, we check if the root, if a root exists between A and C by working out this product, f of A times f of C. So f of A times f of C, now our f of A is what we have. A is what we have here. Our A is 1.125. And our f of A is this, 0.306176,156. That's our f of A. That's what we put here. We multiply this. As you can see, that is positive multiplied by our f of c. Our f of c is what we have just worked out here. It's a negative value. So some value which is positive multiplied by some value which is negative. So you multiply some negative numbers times positive, you're going to get a negative like this. You're going to get negative 0.01747234. This is less than 0. So this means that between A and C, our function has crossed the x-axis. Is that clear? Are we clear? All right. So as you can see, since our product f of A times f of C gives us a negative value, then it means that between A and C, the function cut the x-axis. Therefore, we can shrink the upper part of the boundary, because right now the boundary, the upper part is at 1.5. So we can make our C become B. So our C, we make our C become B, so that B becomes 1.3125. Like this. Are we clear? And our f of C is now going to become our f of B, which is going to become minus 0.057066,233. So with this adjustment, now our boundary AB now becomes 1.125 for A and 1.3125 for B. Is this clear?
Yes.
Okay. Next, we do another calculation. We calculate a new midpoint C using our old A, which is 1.125, and our new B, which is 1.3125. This. So our new C, or new midpoint, our what we think the solution is, in this case, C is going to be equal to be half A plus B. So our C is going to be equal to half 1.125 plus 1.3125. So that's going to be this plus that. So you end up with C equals to half 2.4375, and this 2.4375 divided by half, you end up with 1.21875. So this becomes our new midpoint, or our new solution. Are we clear?
Yes.
With our new value of c, we now decide to check if our function f of c, if our function at f of c has crossed the x-axis or not. So for us to do that, first we need to work out the value of the function at c. So f of c, which is going to be equal to f of 1.12875. So when you work out this, f of 1.12, f of 1.21875, so we get cos 1.21875 minus 1.21875 plus 1. So we end up with this. We end up with 0.126247315. As you can see, this is positive. So at our midpoint, c equals to 1.21875, our function f of c has got a positive value. Now, the task is to check if there is a root between a and c. Our a at the moment is this. This is our a. This is our a, 1.125, and at that particular value of a, the function has got this value. The function is positive at 1.125. The function is positive. So we work out the product of f of a times f of c to see if our function cuts the x-axis between a and c. So f of a times f of c. F of a is what we have here. This is our f of a multiplied by f of c, which is what we have here. It's our f of c. So as you can see, this is a positive valued function. It's positive. Our function is positive at a, and our function is positive at c. So if you multiply these values, you end up with a positive value, which is greater than 0. So since our product f of a times f of c is positive, this means that our function has not crossed the x-axis between a and c. Are we clear?
Yes.
So our function hasn't crossed the x-axis between a and c. So if the function has not crossed the x-axis between a and c, then we make our a become c. So we make a become c. That's what we're doing here. A equals to c equals to 1.21875, and we make our f of c become f of a, which is what we have here. So with this, we now have our new bracket, which is equals to 1.21875 and 1.3125. As you can see, I think our bracket is sufficiently small enough. Is that clear?
Yes.
So once our bracket is sufficiently small enough, we work out a final midpoint, which is what we're going to take as our final answer, or the root to this particular problem, this particular function. So our a, which is now new, is 1.21875, and our old b is 1.31275. So our c is going to be equal to half a plus b. So that's going to be c is equal to half 1.21875 plus 1.3125. So when you do that, we end up with c equals to half 2.53125, and that's going to give us a c which is equals to 1.265625. So this is going to be our value of c, which is going to be our final root. Then also, you probably want to find out what is the value of the function at this final midpoint to see if you are close to 0, because the root of a particular function is the value of c, which makes that function have a value which is equal to 0. So f of c is going to be equal to f of 1.265 625, and that's going to be cos 1.265 625 minus 1.26565 plus 1, and you get a value which is equal to 0.034833159. So we can see that this particular function at this particular point is very, very close to 0. It's not exactly 0, but it's very, very close to 0. Are we clear?
Yes.
Okay, so basically, in a nutshell, this is how bisection goes. You have any questions? Okay.
I'm okay.
So the only problem which is there with bisection is, when do you stop? Are we clear? When do you when do you stop adjusting the bracket? How are you supposed to know? How can you know ahead of time? Because the whole point of us doing this, if there is a way of finding a solution to a nonlinear equation like we have shown like this, the whole point of us doing this is so that we don't have to do this by hand. Are we clear? The whole point is so that we can use a computer to do this, which means that at some point you have to write your computer program which is going to be working out these nonlinear equations for you. Whether your thing is going to use bisection, that's fine, or it's going to use some other method, that's okay. But with bisection, it's important that at some point you tell your program, say, okay, fine, when the difference between A and B is this much, is smaller than this value, then you can stop. Are we clear?
Just repeat that one.
I'm saying that at some point you need to tell the computer to say, when the difference between A and B is a certain number, because A and B, as you're adjusting your bracket, they keep on getting closer and closer to each other, right?
Yes.
Yeah. So you can do this adjusting the bracket for as many times as you want. However, maybe you don't want to do it for as many times as possible. Maybe you're happy with a certain value, okay? So you can, ahead of time, set to say, I will be happy with a bracket which is smaller than this number. Are we clear? The thickness of your bracket, you can set, say, fine, when the bracket is this size, when the thickness of the bracket is a certain number, then you can tell your computer program to stop. Are we clear?
Yes.
Okay. Now the size of the bracket you want the program to stop at. Say when the bracket is smaller than this, then you want it to stop. That is what is called the tolerance of your calculation. So the next time we meet, which is on Wednesday, we're going to see how you can work out the tolerance of a calculation ahead of time, or you can just set it yourself, whatever it is you're going to be happy with. But it's always possible to work out how many times you should do this bracketing thing. Okay, so when we meet on Wednesday, we're going to look at how to make a bisection, how to set the tolerance so that your bisection program can stop. Otherwise, it's just going to continue squeezing and shrinking the bracket until, I don't know. Okay, so unless you've got any questions, yeah, for now, with what we have done, this should be enough for you to answer an assignment problem on bisection. It should also be enough for you to answer a test problem on bisection. It should also be possible for you to answer an exam problem on bisection with these two examples you've looked at, because I believe now you've got a good idea of what is involved.
Yes.
Okay, So when we meet on Wednesday, I'll send you a link. On Wednesday, we're going to look at how to stop a bisection, and we'll start looking after how to stop a bisection. Then we'll also look at other methods, the open methods. So we'll look at how to stop a bisection. Then we also look at the open methods. Then start looking at the open methods. Then hopefully over the weekend, we can look at how to use Python to do your bisection, to do your open methods and stuff like that, and probably try to create some programs which can do that.
Okay.
Yeah. So that by the time we come that other next week, we are done with this chapter. So hopefully, if we stick to our timetable, next weekend this chapter should be done.
Okay.
Yeah. Okay. So I sent you the PDF on your WhatsApp. Did you see it?
Yes.
Okay. I will send you this one also on your WhatsApp. So I'll keep on sending the updated PDF on your WhatsApp, and I'll also upload the video to YouTube.
Okay, I appreciate. And then I was also asking for the other chapters of Python, more especially the ones in PDF, because the other one I printed it out, but for the other sections I don't have. For the other chapters, I mean.
From what chapter to what chapter? The last ones you have?
I think that. Okay, I'll confirm. Then I'll WhatsApp.
Okay, fine.
But
Okay.
I think from 9, is it 9B?
Okay.
The rest I don't have.
Confirm, then let me know, then I can send you on your WhatsApp.
All right.
Okay.
Thank you.
All right. So see you on Wednesday.
See you then.
All right, cheers.